Imagine floating in the vastness of space, surrounded by the quiet emptiness of the cosmos. Stars twinkle faintly in the distance, while the darkness of space stretches out endlessly around you. Suddenly, something unusual catches your eye. A point in space where light seems to vanish, as if swallowed by the void. Hi, welcome to Space Nerd 101. We're brand new to YouTube, and if you subscribe, you'll find the answers to your space and universe questions on this channel. Let's explore together. As you drift closer, curiosity pulls you in, and you realize you're approaching one of the universe's most mysterious and terrifying phenomena, a black hole. Instinctively, you try to turn back, but it's already too late. The gravitational pull of the black hole is too strong, and you find yourself being drawn in, faster and faster. The sensation is unlike anything you've ever experienced, as if the very fabric of space is pulling you towards an unknown fate. Ahead of you lies the event horizon, the point of no return, where even light cannot escape. Your mind races with questions. What will happen once you cross this invisible boundary? Will you be stretched into a long, thin strand of matter in a process known as spaghettification? Will you be crushed under the immense gravitational forces? Or could something even stranger, something beyond our current understanding of physics, await you on the other side? The fear and curiosity intermingle as you hurtle toward the unknown, realizing that you are about to become part of a cosmic mystery that has baffled scientists for generations. And so you're left wondering, with the black hole's dark maw growing ever larger before you, what truly happens if you fall into a black hole? As you continue to fall, the surroundings become increasingly distorted. The light from distant stars starts to bend around you in strange, incomprehensible ways. It's as if the universe itself is warping, bending to the will of the immense gravity pulling you inward. You notice that time itself seems to be slowing down. Moments stretch out, seconds feel like minutes, and minutes feel like hours. This phenomenon, known as time dilation, is a direct result of the black hole's immense gravitational field. For an observer far away, it would seem as if you are frozen in time, stuck at the event horizon, never quite falling in. But for you, the experience is entirely different. You feel yourself moving faster and faster, yet everything around you is slowing down, becoming more surreal with each passing second. The idea that time can be stretched and warped is mind-bending, yet here you are, experiencing it firsthand. As the black hole's gravity pulls you closer to the event horizon, your body starts to feel the effects. The gravitational pull on your feet is much stronger than the pull on your head. This difference in gravitational force, known as tidal force, begins to stretch your body. It's a strange, almost unimaginable sensation, as if you are being pulled apart, atom by atom. This is the process scientists call spaghettification, a fittingly bizarre term for such a bizarre fate. Your body is elongated, stretched out into a long, thin line, like a piece of spaghetti. It's a slow, torturous process, yet you remain conscious, aware of every agonizing moment. And yet, despite the pain and fear, there's a part of you that can't help but be fascinated by what's happening. You are experiencing something that no human has ever experienced before, something that is as much a mystery to science as it is to you. As you approach the event horizon, you can't help but wonder, what lies beyond this point? Is it truly the end, or could there be something more waiting for you on the other side? The event horizon is often described as a one-way door. Once you cross it, there's no going back. But what if somehow you could survive the crossing? What if there's another side to this terrifying experience, something that goes beyond our current understanding of the universe? These thoughts swirl through your mind as you continue your inexorable fall toward the event horizon, drawn ever closer to the ultimate unknown. To understand what happens when you fall into a black hole, it's essential to first grasp what a black hole actually is. At its core, a black hole is a region of space where the gravitational pull is so strong that nothing, not even light, can escape from it. This immense gravity is the result of a massive star collapsing in on itself at the end of its life cycle. When a star that is many times the mass of our sun exhausts its nuclear fuel, it can no longer support itself against the force of its own gravity. The star's core collapses under this gravitational pressure, compressing into an incredibly dense point known as a singularity. Around this singularity lies the event horizon, the boundary beyond which nothing can return. The event horizon isn't a physical surface. Rather, it's a point of no return. Anything that crosses this threshold is doomed to be pulled into the singularity, crushed into an infinitely small point where the laws of physics as we know them break down. The idea of a singularity is one of the most puzzling concepts in physics. At this point, gravity becomes infinitely strong, and space and time as we understand them cease to function normally. Scientists are still grappling with the implications of what happens inside a black hole, as the equations of general relativity predict this singularity, yet offer no explanation for what occurs at this point. It's here that our current understanding of the universe reaches its limits. So what does this mean for someone falling into a black hole? As you approach a black hole, the gravitational forces begin to intensify dramatically. The closer you get, the stronger the pull. But it's not just the strength of gravity that changes. The nature of space and time themselves begin to warp around you. One of the most famous effects of this intense gravity is spaghettification, where the differential gravitational forces stretch objects out into long, thin shapes. This happens because the force of gravity is much stronger on the side of an object closer to the black hole than on the side farther away. If you were to fall feet first into a black hole, for instance, the pull on your feet would be far stronger than the pull on your head, causing your body to stretch out like a piece of spaghetti. But spaghettification is just one of many bizarre phenomena associated with black holes. As you fall closer to the event horizon, time itself begins to behave strangely. From your perspective, time seems to slow down, while for an outside observer, you would appear to be frozen in place just above the event horizon. This effect is due to the intense gravitational field of the black hole, which warps space-time to such an extent that it distorts the flow of time itself. This phenomenon, known as time dilation, means that the deeper you fall into a black hole, the slower time moves for you relative to the rest of the universe. If you could somehow survive the journey past the event horizon, you would continue to experience increasingly intense gravitational forces and time dilation. But surviving beyond the event horizon is purely theoretical, as no known material or living being could withstand the extreme conditions present in this region. However, these effects are just the beginning of the mysteries that black holes present. Once you cross the event horizon, the true enigma of the singularity awaits. What happens to matter that falls into a black hole? Does it simply get crushed into the singularity, lost forever? Or is there some other process at work, something that we have yet to understand? Scientists have been debating these questions for decades, and despite significant advancements in our understanding of black holes, many of these mysteries remain unsolved. One particularly perplexing issue is the information paradox, which arises from the question of what happens to the information about the physical state of objects that fall into a black hole. According to quantum mechanics, information cannot be destroyed, but if an object falls into a black hole and is crushed into the singularity, where does that information go? This paradox has led to some of the most exciting and controversial theories in modern physics, including the idea that information might be preserved in some form on the event horizon itself, or possibly even in a parallel universe. But these ideas are still highly speculative and remain at the frontier of theoretical physics. As you can see, black holes challenge our understanding of the universe in profound ways. They force us to reconsider the nature of reality itself and to confront the possibility that there are aspects of the cosmos that are beyond our current comprehension. As you get closer to the event horizon, the mysterious boundary of a black hole, the environment around you starts to change dramatically. The gravitational pull intensifies with every passing moment, drawing you inexorably toward the unknown. The light from distant stars bends and warps around you, creating a distorted, almost surreal view of the cosmos. This effect, known as gravitational lensing, makes the universe appear twisted and stretched, as if you're seeing it through a funhouse mirror. The closer you move towards the event horizon, the more pronounced these distortions become. Space itself seems to compress and stretch, creating an unsettling sense of disorientation. Distances that once seemed vast now feel oddly contracted, as if the fabric of space is being squeezed. Time, too, begins to behave strangely. From your perspective, it feels like time is slowing down, each second stretching out longer than the last. This phenomenon, known as time dilation, is a result of the immense gravitational forces at play. For someone observing from a safe distance, it would appear as though you are moving in slow motion, inching ever closer to the event horizon. But for you, time feels both drawn out and accelerated in a confusing, disorienting way. The gravitational forces acting on your body become more extreme as you near the event horizon. The pull on your feet is significantly stronger than the pull on your head, leading to a bizarre stretching effect known as spaghettification. Your body is being elongated, stretched out like a piece of elastic, while also being compressed by the intense pressure. This sensation of being pulled and compressed at the same time is unlike anything you've ever felt, a disorienting combination that defies logic. As you approach the event horizon, the darkness surrounding you becomes more intense. Light from the outside universe struggles to reach you, swallowed up by the black hole's immense gravitational pull. It's as if you're entering a realm where light itself cannot exist, a place of absolute darkness. The closer you get, the more oppressive this darkness becomes, until it feels as though you are being enveloped by the black hole itself. At the same time, the temperature around you begins to rise. The intense gravitational forces within the black hole generate enormous amounts of heat, as particles and radiation are accelerated to near-light speeds. This heat is unlike anything found in the normal universe, a searing, all-consuming fire that threatens to destroy everything in its path. Yet despite the overwhelming heat and pressure, there is a strange stillness in the air, a silence that seems to pervade everything. It's as if the very essence of reality is being stripped away, leaving behind only the barest remnants of existence. As you approach the event horizon, you are confronted with the ultimate question: what lies beyond? Crossing the event horizon is unlike anything you can imagine. Once you pass this point, there's no turning back. The black hole's gravity pulls you in with unstoppable force. Space and time become so distorted that they start to lose all meaning. From the outside, you would appear frozen in time, forever teetering on the edge. But for you, the journey continues inward. The light from the outside world fades completely, leaving you in utter darkness. The intense gravitational forces continue to stretch and compress your body, making every moment feel like an eternity. The laws of physics as we know them no longer apply here. What lies ahead is a mystery, a place where even our best theories break down. You are now in the realm of the singularity, where the true unknown awaits. Beyond the event horizon, your fate is sealed. The black hole's gravity becomes overwhelming, drawing you relentlessly toward the singularity. At this point, everything you know, space, time, and matter, collapses into the unknown. Your body and any information you carry are crushed and compacted beyond recognition. Scientists speculate about what happens next, but the truth remains a mystery. Some theories suggest that information might survive in some form, while others propose it's lost forever. As you plunge deeper, you're venturing into the most enigmatic region of the universe, where no one truly knows what happens. Black holes may hold the answers to some of the universe's biggest mysteries, but what if I told you that they're just the beginning? There are even more bizarre, mind-bending phenomena out there, just waiting to be explored. What if I told you that time travel, parallel universes, or even life on other planets might not just be science fiction? Curious? Then make sure you hit that subscribe button, because in our next videos, we're diving into the next big cosmic mystery that could change everything you think you know about the universe. You won't want to miss it. See you on the other side.